Thank you everyone.
Good morning, Dr. Ram Pradeep sir.
Good morning, sir. Good morning.
Sir, good morning, sir. Dr. Thirujanam sir. Good morning, sir.
Good morning.
Good morning, sir. Sir,
Ram
Ram
Pradeep.
Sir, good
Pradeep
morning,
sir,
sir.
this presentation.
Good morning, sir. Good morning, sir.
Sir, shall we start the session, sir?
Yes, sir. Yes, sir. We can.
Yes, sir. We can.
Am I audible, sir?
Audible, sir. You are audible.
Okay. Okay.
Michael, clear.
Very good morning to all. This is the second session of day 2. The session is on special concrete in construction industry by Dr. G.S. Ram Pradeep, Professor, Kongu Engineering College. Sir, any voice கேக்குதுங்களாங்க sir? Ram Pradeep sir?
Yes, sir.
Am I
Yes, sir.
audible,
You are
sir?
audible, sir. You are audible.
Thank you, sir. Brief intro about Dr. Ram Pradeep, sir. Dr. G.S. Ram Pradeep is working as an associate professor in the Department of Civil Engineering at Kongu Engineering College, Perudurai, Erode, Tamil Nadu, India. He has completed his graduation in civil engineering from Kongu Engineering College in the year April 2008 and completed his master's in structural engineering from Mannariyamman Institute of Technology on May 2010. He was awarded 2 gold medals for his outstanding performance in structural engineering. He did his PhD in the field of internal curing concrete under the Anna University, Chennai, and completed successfully in the year May 2017. He has published more than 25 papers in reputed conferences and 7 papers in a reputed international journal. He is the recipient of various awards, includes IEI National Young Engineer Award, American Concrete Institute USA Collaboration Award for the IoT-based RC concrete water race from Zhejiang University, China, National Concrete Canoe Challenge under ASCE SRM Student Chapter, ACI International Travel Stipend, ACI Chapter Activities Award, Best Mentor Award, Best Paper Award, IEI Young Engineer Award, Erode Chapter, Dr. APJ Abdul Kalam Award, IEEE Consumer Society, etc. from the government agencies and reputed organizations. He has successfully awarded and completed a research and seminar grant over a lakh from various agencies like AICTE, CSIR, TBI, KEC, etc. Recently, his project team was sponsored with an amount of rupees 6.69 lakhs from IIT Madras, US Consulate, Chennai, fellowship as a startup grant in the theme of Carbon Zero Challenge and one Innovation Excellence Award, a highest recognition from IITM and USA Consulate General, Chennai. He has awarded 2 design patents, patent number 305934 for the project Carbon Dioxide Curing Chamber, and for Canoe, patent number 328235 under Government of India. Recently, his project, Eco-Friendly Construction Blocks from CND Debris using the innovative CO2 sequestration technique, was considered by IITM Incubation Cell and ENGSUI, Engineers India Limited, a Government of India undertaking company, for an amount of rupees 21 lakhs at New Delhi. Very recently, this invention is awarded in Hackathon 2021, a Make in India scheme launched by Honorable Prime Minister of India, Sri Mr. Narendra Modi. Now, I invite Dr. G.S. Ram Pradeep, sir, to present the session. Thank you very much to all. Thank you.
Sir, is it possible to share the screen?
Yes, sir. Yes, sir. We are sharing now.
Okay.
Wait. Share பண்ணிடலாமா? Sir, Ram Pradeep, sir.
Is it possible to go for slideshow mode, sir?
Slide is visible, sir.
Yes, slide is visible, sir, but I'm asking you just please go to slideshow mode, sir.
F5
Okay, sir. Sir, is it okay now?
No, sir. I'm not getting the full screen mode. Or you just close, sir. Shall I try?
Okay, sir. Okay.
Just close it, sir. Is my screen visible, sir?
No, sir.
Now, sir? Hello?
Visible now, sir. It is visible now.
Is it visible, sir? Is it okay, sir?
Okay, sir.
Okay. So, very good morning to one and all gathered for the faculty development program by Atal AICTE. Today, I'm going to handle or take or share my views regarding the special congress, which is the prime most important concern in the civil engineering field, right? So without the special concrete, we will arise a question in our mind whether the structure will withstand or not. Just by the term special, within the quotes special, we should not inspire or we should not admire to that word, because if we are coin one word to the along with the other word, it should possess the meaning, right? I am separating this to special plus concrete. In earlier days, if we see that there are no such terms called special concretes or sustainable concrete or modern concrete or advancements in concrete technology, nothing special terms have been coined in the previous historical or traditional monumental constructions. Hope we know that there will not be any much IS codes in the earlier periods, but still the construction, the structure is withstanding, right? But here in the modern days, we are using the term called special concrete. The term special, which should possess a function inside the concrete, is called a special concrete or a modern concrete. I have conveyed a meaning for my presentation. But the second half, a special concretes in construction industry, right? Ultimately, if we are making one product, if we are developing one element, or if we are inventing, see, there is a difference between innovation and invention. right? So every innovation, right, we can't call it as an invention, but every invention, right, is under the innovations. Through innovation only we are getting the invention. By making various trial and error, various iterations, we are getting ultimately the invention. But here there is a lot of gap between the academia and the industry. Why I am telling is, if you see the research aspects globally, the countries like US, Canada, China, these peoples and all, they are making the research, or in other words, they are making the invention directly applicable to the construction industry. In other words, I will tell that they are taking the problem statement from the industry. They are making the collaboration study between academia and the industry. Both people will mingle together. And finally, they are obtaining one fruitful solution. Immediately, we can't get the fruitful solution. Hope we know that it will take a time after many trials. So after making various iterations, they are getting a fruitful solution, which is need of the day. So in India, we are facing some issues and there is a lot of gap. We are also focusing with the industry, but compared to the advanced countries or developed countries, we need to still focus much more, and the gap should be reduced. It has to be fine-tuned between the industry and the academia. So why I am telling is, recently I have experienced the feedback or the problems with the industry to the product what I have made from the fund obtained from the Government of India, that I would like to share in the upcoming slides. So I insist the research scholars, budding engineers, those who are willing to go for the research either in part-time or full-time, they need to take a particular, a narrow down problem statement from the industry which is associated now, and you just fabricate your own methodology. Don't make your shielding that this project, if I am taking, it will not have any instruments. So I am not having any instruments in my institute, or I am not able to find much data, right? Just transform your technology to the interdisciplinary approach, that it is possible in the Congress itself, where I have somewhat tried in my laboratory using IoT systems, Internet of Things systems, that it can be controlled by the remote applications, where that IoT based research is coming under the smart applications, right? Here in this presentation, I would like to cover you people where and all the special concretes is more important, what are the different types of special concretes, and what are the projects we are working with and we have completed, and what are the inventions we have made so far, what are the main funds that we can obtain from the Government of India using these special concretes concept, what are the industrial expectations, and finally, how you can make the collaboration research with the inside the country as well as country to country. I will tell you one example before proceeding to the next slide, because I have not pointed that concept in this presentation. Nowadays, you people know that carbon emission, CO2 emission is increasing nowadays, creates global warming effect, and many researchers are selecting how we can reduce the emission of CO2. Not only the civil engineering people, all the people, all the technologists, they are searching how to reduce the emission of CO2 into the atmosphere by preserving the country, right? So if we are going to the metro cities in the month of March or in the month of May, so we can able to face much CO2 emissions. The hazardous gases precipitation in the atmosphere will be much more. If you are going for the northern parts, we can see in all places that the contaminants level is like this. It is in a dangerous zone. A security alert will be given. So, instead of going to cement, what are the other special elements we can go with? For that, IIT Madras, in tie-up with IIT Delhi, they are going with the special type of cement called LC3. I think this type of research will be mostly useful for the budding engineers, those who are in the final year. They are expecting what is the current trend of the project we can do with, and the PhD seekers, those who want to pursue their research, they will try to explore the advancements in the topic in order to get more details. So, in IITM, LC3 based cement, that is limestone calcined clay cement, is an alternative to the cement technology. So they are using the limestone material and they are calcination, producing the cement based material for the concrete structures. In addition, IITM, IIT Delhi, they are making the tie-up with Switzerland, a professor called Karen Scrivener, right? So they three together are working a lot, and if you want to explore more details regarding to LC3 based material, you can refer Dr. Yuvraj Dandabani. He recently completed his research from IITM, and his mentor is Professor Manu Santanam. So you can refer more paper to him if you want to do with LC3 based material, right? So like this, in the upcoming slides, I would like to show you the different types of special concretes and in connection with the construction industry. You can see the photo. We have placed a concrete, a decorative material, which I will explain you in the coming slides. What are the special materials we have used here to manufacture this element, and what is this complete application of this element, and what are the research aspects and research areas that the students can place with. Nowadays, there is much not employment is coming, means the students can approach the crucial countries like US, lot and lot of material research is going on. I will explain you where the students can focus, right? First of all, what is meant by a special concrete? I already told you that concrete which performs or which do a special type of function inside the concrete is called special concrete. So here, how we can achieve the special concrete? It can be made by using the additives, right? You can go with either mineral admixture or chemical admixture. If you are going with special type of reinforcement, or if you are going with special type of meshes, alternative to the steel mesh, what usually in the ferro cement the people will go with. And in the special type of fibers, both natural or artificial fibers, anything, if you are adding in addition to the general concrete ingredients, we can call it as a special concrete. But logically, we should not. We can call them as a special concrete, but logically, if we think that, we should not coin that as a special concrete, because in the first point, I mentioned that it should possess a special function. So usually my guide will tell that if we are adding a dust, what it is available in the roadside, whether we can call it as a special concrete. There is a waste paper is available near the roadside. A polythene paper is available. Whether we can add inside the concrete additives and we can call it as a special material? No. If I am adding, what is the function of that polyethylene material will react, right? So that is all about the special concrete. Here I would like to point that making a special concrete is good enough. I agreed completely, because nowadays the infrastructure is booming. Without infrastructure, we can't give the clarity of the country. So if we are entering into Dubai, we can see the huge high-rise buildings, right? Their complete infrastructure, how their maintenance, modern materials they have incorporated, like that. So as the infrastructure is moving on, we should not project only in the special concrete. Also, it should satisfy the sustainability. Like what we have already studied in the RC design. Earlier it was working stress, then it migrated to ultimate load, then finally to limit state method. Just we will forget about the limit working stress method. We will concentrate only on the ultimate load and the limit state. What is the limit state is telling? In addition to the load carrying capacity, we need to take care of the serviceability. In long term, in long run, my material should withstand. Right? Assume that I am giving you a conditioned statement. You are taking one research regarding a alternative material for the fine sand. Hope you people know that in 2015 and above, there is a huge depletion of the river sand, and entire construction industry, they are moving for alternative sand, either to M sand or for any other polymer sand. You are making, when you are going to the industry and you are proving that I have manufactured, I have invented one sand which is a best giving result than the river sand or M sand. Do you think that the industry will buy? Even nowadays, the people are very few people are going to get for a modernized paints for their infrastructure? How many people they are knowing there is a special technology called translucent concrete or transparent concrete? It is one of the decorative concrete where the visibility of one person can be viewed in the opposite side through the wall thickness. How many persons will know? If you are marketing that product to the industry or to the rural background of the people, even in some of the urban areas, whether the people will come and immediately buy your product because they have already stick to that traditional product, right? Now, here there is a big question mark. We are making so much amount of research. We are spending enough time in the laboratory. We are inventing much more based on trial and error. And another question mark, how we are marketing? That is a big question. So that here, before proceeding with the research, we need to search the problems associated with the industry people, the industry executives, the top industry executives, right? After getting the problem statement from them, you need to come back to the academia, search it out in the advanced kind of journals like Taylor and Francis, Elsevier, Cement and Concrete Composites, Magazine of Concrete Research, Journal of Cleaner Production, like that. If you want, if you people are doing with waste management, you can refer the Journal of Cleaner Production to explore many things. And if you are doing with the enzymes like research, you can go with biotechnology or microbiology based things. And if you are going with interdisciplinary research, you can go for International Journal of Civil Engineering by Springer, like that. So just get all the details, make an interaction with the industry people, and filter one solution, filter one research area, and make the research. Without knowing the fundamental concepts and how to make the research, many people are working now, right? So your research area should be fine-tuned, and even many people are doing in the special concretes. Simply they are keeping experimental research on fiber reinforced concrete. Do you think that it is a narrowed down topic? If you are willing to apply for postdoc, if you are giving the SOP, first they will ask the SOP, statement of purpose. If you are going for SOP, what content you will write? Because you have experienced with varieties of fibers, obviously you will go for the tensile strength. We know that in the bottom flexure member, the tensile strength will be to be enhanced. For that, we are adding the fibers. Many people, we are not knowing how much aspect ratio we need to go with. For that, make the collaboration study and do the research. So in this criteria, I would like to make the presentation starting with recycled aggregate concrete, lightweight concrete, self-compacting, which will be called it as SCC, self-curing concrete, which is my area in my research, high strength concrete, high performance, high density, geopolymer, whisper concrete, polymer concrete, FRC, vacuum concrete, bacterial and no fines concrete. So in this presentation, I would like to give the overall picture where it will be mostly useful for you people when you are going for the title selection. Right? Am I audible, right? Am I audible?
Yes, sir.
Okay, thank you. Okay. In the previous slide, I have shown you the varieties of advanced concretes. But do you think all the concretes can be applicable to all the places? Do you think? No. I will tell you why. As a research scholar, as a faculty, as the perseverance of doing research, we should be in position to answer for the questions why, where, the reason out questions, the defending questions. Let us take one example. The second point is mentioned as availability, right? I am going to the previous slide and I am mingling with self-curing concrete. Is it possible to tell me whether there is a relation between self-curing concrete and availability? Let us discuss. Do you think there is a interlinked concept between the self-curing and the availability in the limitations? I am telling yes. How many people are raising the hands with me? The answer is yes, because when we will go for self-curing concrete? We will go when there is a demand in water, demand in getting the water. Take an example of South Africa, right? And the Gulf countries. The obtaining of water, what is getting for our country, it will not be like that for their countries, right? So, how they can make the curing and how they can make the water for the mixing? Each 1 meter cube of concrete requires 3 meter cube of water for the mixing and curing purpose. How we can get the water? Without water, you people know that the hydration will not occur. As we know that the box compounds, what we are adding, that is C3S, C2S, C3A, C4AF, whatever it may be. If the water molecule is getting react with that box compounds, what is the solution we are getting? Calcium silicate hydrate in a well bonded structure we are getting. That too, the byproduct is calcium hydroxide, CaOH twice, is getting precipitated. Why the concept of mineral admixture has been came? Due to improper hydration, right? CSH gel has not been formed. Why the CSH gel has not been formed? Only due to the material? No, not sufficient water. So, if I am going for self-curing concrete, I am already incorporating or intruding the water-based chemical admixture, which will hold the moisture inside the concrete, that too inside the fresh concrete, throughout the lifetime of the period. Okay, it is holding. How you will prove that? I am telling that I am telling you that I have added one chemical inside the beam during the casting. And I am telling you that I have added the self-curing agent. Initially, you also believe. But how we can ensure that whether I have added or whether it is possessing that function or not? So the output can be measured from the microstructural study. Whether the pores has been filled or the matrix has been covered by the CSH, or there is no visibility of the shrinkage cracks. See, shrinkage cracks also occurs due to the bleed water. It is called autogeneous shrinkage, right? So there is a limitation for one particular purpose. If there is no availability of one element, I am going for a special concrete. I will tell you another application. There is the gap between the reinforcements, the mat rod. It seems to be both main reinforcement as well as the distribution bar. seems to be good. Why it is necessary for going to self-compacting concrete? We can go for a needle vibrator. For example, if I am going for constructing the residential building, I am putting a roof slab over the first story in my home. Whether I need to go for SCC? Not necessary. I will not tell no. There is a difference between not necessary and no, and should not. See, it is not necessary because I can go for a conventional type of material and I can give the easy vibration and I can make the concrete to be smoothened. Right? I will come for next limitation, zero pollution. Why I have to go with zero pollution? See, I am giving one topic, experimental study on vacuum dewatering system. Experimental study on vacuum dewatering system. This is my title. And in my objective, if I am telling that it creates zero pollution, whether your title and the objective is getting synchronized? No. Your vacuum dewatering, how it is making the zero pollution? Whether the concrete is not emitting any hazardous substance to the atmosphere? When the hazardous substance is getting? During the manufacture of the material itself, it is getting. In cement factory, we are producing the cement in a high incineration. When we are using, we are getting the high carbon emission. So that we are seeking a different solution to limit the CO2 emissions. Right? For that, there is a separate category of a special concrete that I will show in the next slide. Cost. This is the one everybody is asking. Sir, if I am going for special concrete, whether I can reduce the cost for per meter cube of concrete? Right? How you will decide? Without making number of experimental work, how you can decide? So that, why I am telling is, many people will give in the title itself that cost efficient product using these kinds of material, like that they will give. No. Unless until if you are not prove, you should not mention the titles like cost enough or eco-friendly or so on so. Right? So this is all about the limitations which I have merged with these kinds of special concretes what I have mentioned here. So this is the one is called RAC, recycled aggregate concrete. For this project only, initially we got the startup grant of 5 lakhs from IITM and USA Consulate General Chennai in the theme of Carbon Zero Challenge. Was initiated in the year of 2017 June. This is the first time India, in collaboration with IIT and USA Consulate, they have coined this problem statement. And don't think that this is only for the civil category. This is applicable for all the categories. I think after the pandemic, IITM will again launch the system. Those who are really interested to go with reducing the carbon emission, you can apply for that scheme. You can get the fund and you can develop your own product. And you can, if you are coming in the top category, they are ready to, the host, they are ready to tie up your product with the industry people. And you can also make the incubation. Right? Here, how we have started and how we have made the special concrete like recycled aggregate concrete. You can raise the question that how the CO2 emission can be reduced using the recycled aggregate concrete. Here what we have made is, we have taken two problem statements into a single problem statement. One, nowadays, if you see that many people are dumping the waste as it is in the roadside and many parts of the places. And government is frequently telling that don't dump the waste in the open yard, which will create a disturbances to the public and in turn disturbances to the groundwater pollution also. And if there is no aerobic process, then it will lead to the air pollution also. So what we have made is, we would like to give one solution for the C&D waste, that is construction and demolition waste, what the people have dumped in the site. We have taken the problem, and in the left part you can see that I have categorized what are the countries they are emitting the different CO2 into the atmosphere, taking from China, US, in European countries and India. Starting from 1960 to 2017, we have freezed because we submitted our document in the year of 2017 June, and how much amount of CO2 emissions per ton, right, the country is emitting. And if you see that India projected carbon emission of 2.6 billion tons in 2018 would account for 7% of global CO2 level. Normally, if we are going with accelerated carbonation test, we will give the input of 3% because the average CO2 in the atmosphere is 3%. Like that, we will give it. But you just see that slide, 7% of the global CO2 levels, which are hit all the time high this year. So in the right side bottom where I have highlighted, the government of India, they have called for the researchers to give the solution, because India is the third largest contributor of CO2 emission, which was published in the Hindu in the December 6, 2018, as well as Supreme Court. They are pointing how to rectify the dumping of construction solid waste, which was came in the Hindu paper in the same year, 2018, as well as the Gurugram. The MCG has identified 15 new village spots, how to rectify the dumping of the C&D waste and how we can effectively dump the C&D waste without affecting to the public. So it was published in the 2018 Times of India. So these are the prime factors we have taken, because when we are making a product, if we are going to the industry person should not ask why you have manufactured this, right? So these have the problem statements we have taken. And in the left part, if you see that is the machine, it is a semi-automatic interdisciplinary equipment we have manufactured, and we have got the design patent in the year of 2019. Excuse me, hello? Am I audible? Am I audible? Some disturbances is coming actually. Okay. So this is the one we have manufactured our own design, where the central cylinder, what you are seeing, is of stainless steel of 5.5 feet height. And we have developed our own coding with the help of computer science department for all the kinds of inlet and outlet. We have given a password, and there is a hopper at the left part where we have to dump the C&D debris, and the dumped C&D debris, after giving the password, it will go to the cylinder. And the top of the cylinder, we have fitted the CO2 sensor, where we have purchased from Austria, and the very famous company, Power Limited company, ABB, we have fitted the pressure gauge. And to the right side of the cylinder, we have fitted the relative humidity meter, where we have obtained from Vaisala, which is the very precise relative humidity measurement, to monitor how much amount of humidity level is there in the dumped C&D debris. And altogether, we have connected to the panel, what you are seeing in the right side board. And in our study, what is our ultimate objective is, we have manufactured the construction blocks, especially the paver blocks. This is the design what we have made only for the PCC. We haven't went for RCC because you people know that when the carbon dioxide reacts with the RCC, the steel, the pH level will get altered from 12 to 13.5, which will be the normal good possessive nature for the concrete. It will get reduced due to the reaction of CO2 with the steel. Also, the passivating layer also will get destroyed. Right. So the automatic, semi-automatic machine we have did for both manually as well as for the automatic. We can compare. And in the center, you can see the CO2 cylinder where we have passed the pressure into the stainless steel container. And in the left part down, you can able to get the compressor where we have obtained from China. And these are the setup we have manufactured. And this is this project, it got highest recognition from Carbon Zero Challenge in IITM. And on the right side, you can see the different types of power patterns we have made. And you can ask me the question, sir, this is already available. These kind of paver blocks and all are already available. But here what we have did is, as I already coined, we have made with CND debris and we have passed the CO2 also. And we studied for what is the reaction of CO2 with the CND debris. Because in CND debris, we will have already the calcium silicate hydrate and the calcium hydroxide. That calcium hydroxide, when it is react with that CO2, what are the, how the calcium carbonate precipitation is occurring, right? So if that calcium hydroxide, if it is react with the CO2 for the RCC, tends to form H2CO3, carbonic acid, which will be formed, which is a negative impact to the concrete layer, right? So that your steel is getting destroying. So initial study we have made for the PCC layers, and we analyzed for the cost estimation also. We have partly did for the hollow blocks. And still the research is in pipeline. We are working with that next level, right? So this is a storyboard where I have explained with the previous slide that we are collecting the CND debris and we are pulverizing. Immediately after the collecting of CND debris, we can't directly pour that CND in their own form in the hopper, right? In the third photo in the top, you can see after pulverizing, after grinding, we have to go for sieve shaker for the grading. After grading, we need to choose in which grading we are going to use. Either you are going less than 4.75 mm or if you are using above 4.75 mm. We are using less than 4.75 mm, right? And after grading, we are directly dumping in the hopper. And in the center photo, inlet of CO2, the scholar is giving the pressure. So what we have made is, we have initially decided for 3 pressures, 5 psi, 10 psi and 15 psi, pounds per square inch, that we have controlled in our valve, and we have passed that CO2. That CO2, how much amount of we are passing, that can be monitored in that 6th photo, that is using that rotometer, as well as we are also having the pressure gauge that you can able to get it. And CO2 sensor also we are having. And in the bottom photo, automized control, you can able to get the automatic graph between pressure, temperature and humidity, right? And in the bottom photo, the second, the student is collecting the carbonated CND debris. After carbonation, we have passed the pressure of 5 psi and we have left out for 15 minutes for trial and error. I am telling. You can raise me the question that how you have determined the time. Either we have to left out for 15 minutes or 10 minutes or 5 minutes, how you are determining the time. Because since this is our first trial study, we have left for 15 minutes. And after collecting that carbonated CND debris, we have went for the paver block company for hot pressing, and we made the conventional blocks, that is RAC blocks, right? So we have compared that RAC blocks with that sand blocks. the right side photo bottom, last photo, you can see the left part, the brown color material is the sand blocks. So sand block, like in Foundry, how the people will make it, right? Like that, we have made the sand block. We have inserted holes. That sand block is made with the sodium silicate, right? Na2SiO3 sodium silicate we have used as a self-curing material for silica gel matrix, and we have analyzed how densification it is going with, and we compared the sand blocks with the RAC blocks. We studied for the properties, sustainability properties. So coming to the next topic of lightweight concrete, we people know that where we are not giving much pressure, like the live load, we can go for lightweight concrete. Normal concrete, your density will be around 2200 2400 kg per meter cube. In lightweight concrete, if it is between 300 to 800 kg per meter cube of density, we can mention as lightweight concrete. How we can achieve lightweight concrete? So achievement of lightweight concrete, either you can go for using the less density aggregates, or you can go for any foaming mechanism, or you can going for any other powderaceous material like powdered zinc, aluminum powder or powdered zinc, like that you can go with. So mainly three types we can go. One is either by aggregates, lightweight aggregate, or going by foaming agent, or going by the powderaceous material like powdered zinc or aluminum powder. See, aluminum powder, they are restricting now because it is used for crackers. So it is not, it is like blastable. So for the research, it is not advisable, right? So when I am going for using lightweight aggregates, the microstructural level, we can see the presence of micropores, right? You know that there is a difference between voids and pores. So in lightweight aggregate, you will have micropores. And what is the basic principle it is working is two principles. One is called adsorption. If the water is getting absorbed in the surface, is called adsorption. And absorption is, if it is absorbed by the core material, it is called absorption. And the one of the less drawback is it possesses less strength because it is having low specific gravity, right? Just see the form of pumice stone. The outer texture of the material, you can able to get what is the condition, and you can compare with the normal aggregate, what we are using for our construction, which are getting from the quarry, right? You just compare these two materials, including the weight, including the texture, including the microstructure, including the shear, like that, any, including the crushing, right? So obviously, the crushing strength will be very less for the lightweight aggregate than the normal aggregate, because in the normal aggregate, the density will be more, around 1600 plus kg per meter cube, right? So when you are using or when you are guiding your students for advanced level of research from the undergraduate itself, my humble advice, you people, especially when you are doing in material aspects, just ask them to study for SEM analysis. Many people in their report, they are not going for SEM analysis. It should be in the every material chapter, because that is the one, it is giving provable statement. The research what we are pursuing is correct or not. I will give you one example here. I am adding one enzyme to the cementitious substance, either cement mortar or slurry. Just assume that I am adding for cement mortar. The enzyme what I am adding, I am calling as, it will heal the crack automatically. If I am telling like that, right? How the people will believe in the viva voce examination or defense? I have added bacteria. Truly, I have added bacteria. I am making the checking for the properties. I'm going for compression strength, so on, so blah, blah. Everything I am going for. If I'm going for a beam, 2-meter beam, I'm going for flexural strength analysis, shear strength analysis, deflection parameter, everything I'm going for. Ultimately, what is the question will come into picture in our to our front. You have added bacteria. You have added enzyme. What is the specialty of the enzyme? Whether it is coming under aerobic, whether it is coming under anaerobic, what is its lifetime, like that. Whether it arrested the crack or not, how you have determined. You need to test for the material, take the core concrete, just give it for the microstructural image analysis, observe that whether it has healed the crack or not. Right? Very recently, I think whether you have studied the newspaper or not, one person, they have used the natural material seeds to heal the crack. Natural material seeds to heal the crack. Right? So, SEM analysis is scanning electron microscope. FE means field emission scanning electron microscope in order to assess the internal ability of the particle. Just see the same image of the same pumice stone what I have shown here. This is the outer faces of the one stone. Just see here after SEM analysis, after keeping it in the microscopic image, just see how the particles, the pores and the concave like appearances. So if you are using these kinds of a minute pore like material, obviously your absorption rate will be more. Right? I will give you one material. If you are going for SAP, super absorbent polymer, in the name itself it is called absorbent polymer. If you are replacing with some material for cement or something like that, just try out with. It will drink the water of its own. You are using water again and again, it will continuously drink the water. SAP is like white, like powder. It will continuously absorb the water. See, there is a relation between continuous absorption with respect to the workability. If you plot the graph of your own, continuous absorption will enhance the workability. That I will know that. But you just imagine a chalk piece, you are crushing a chalk piece, you are pouring the water over the chalk piece. Right? How will be the chalk piece? What will be the condition of the chalk piece? It will be like a flour, right? Like that your SAP material will be. So if the SAP material continuously absorbing the water, how it will supply the water to the other concrete ingredients for the effective hydration? That is our task. We need to optimize the material of the SAP, as well as we need to manipulate the correct dosage of the water to be added for the SAP. I just gave the example. There is another material as well. Go for vermiculite. Go for pumice. Right? So it is your challenging task to go for the water manipulation. So for the mentors, if you want to go up with lightweight aggregate project or lightweight aggregate research, The advancements in the material is ceramic glass microsphere, which normally called as CGM, and hollow glass microsphere, which is called as HGM. These kind of microspheres cost quite higher. We have used for one project, for one competition. We have purchased this from Mumbai. At that time, I think by 2015 itself, it costs around 800 rupees per kg, excluding the tax. Excluding the tax, including it's coming around 900 plus. You should understand what is its morphology. Just see. What is the morphology of the microsphere? You just compare this element with this element. Just compare this and this element. Just see how the rounded structures will be. Creates a better lubrication. Dispersion effect will be enhanced. In some cases, if you are fixing M40 plus grade concrete, if you somewhat replace the normal ingredient by highly advanced lightweight material, generally you will go for the workability agent, right? Water reducing agent. At that time, your dispersion effect will be enhanced. How the dispersion effect will be enhanced? Because of the high effective lubrication and the shear will be less between the particles. And your portion will get entirely filled up without the presence of voids. Automatically, the density of the overall membrane will get reduced. So here we went for one case study at that time. In 2015, I'm not very sure about that. They called for one national level event. The host is IIT Madras and ASCE, American Society for Civil Engineers. What they given a problem statement is, we need to row a boat, we need to prepare a boat in a lightweight, and we need to row a boat in a channel. And their specifications are, it should be lightweight, should not absorb water, no painting at the bottom surface, less submerge, and usage of the modern materials may or may not be used. So this is the one they have given. So this is the photo what I have placed in my front slide. Just see the freeboard. We have got around 9-inch freeboard, right? And our ultimate objective, our ultimate task is totally 3 races they will conduct. Before the races, what the people will do in the host institute, they have taken us to the ocean engineering department in IITM. Initially, they weighed the boat, what we have prepared, and without pouring the weight and with pouring the weight, they measured for the freeboard. After making all the initial considerations, they will check for the flaws, whether it is happening or not. If there is huge crack, if it is visible in the surface, they will straight away reject. And God's grace, we are very free from all the defects. And the races will be for 1000 marks, 2 gents persons, 2 male, 2 female, and 1 male and 1 female. They have to make the rowing in a depth of around 15 feet channel, height channel, for a distance of 200 feet length, right? So they will measure the time as well as the how much freeboard after setting they will measure. So we have averagely designed for 80 kg. of the students. And we have used these kinds of materials purchased from the Mumbai for this kinds of research. And this is the one in the 2019, we have won National Championship Award from SRM. And this is the single man rowing boat, canoe. We obtained a patent for this design patent. You can't believe the canoe weight is around 9.8 kg. After making the dressings of by painting or decoration, it's coming around 10 kg. Whereas all the persons from other institutions, they came with minimum of 50 kg, 75 kg, even 142 kg. Even 142 kg. The maximum is even 142 kg. We have did maximum for 9.8 kg and to 10 kg. The time taken for the laps is just 32 seconds to cross around 150 feet. Right? Just 32 seconds. Whereas the average time taken by the other people is around 1.6 minutes. Right? So, for manufacturing, this is the ultimate product we are seeing now. Beyond this screen, the students involving 15 to 18 members, they have made a different types of trials, starting with fabrication of the panel, a single panel. They haven't directly gone for fabrication of the canoe. They went for a simple manufacture of the panel, a lightweight panel. While doing for the lightweight panel, they are in the condition to fix the density. If we are increasing the density, obviously the freeboard will be lesser. Ultimately, the strength will also be lesser. No, freeboard is lesser means strength will be enhanced because the density is increased. So ultimately, we need to fix the density. We need to fix the compressive strength. And when the man is sitting, the buckling, the bending is happening now, that should be resisted. And we need to take care of the buoyancy force also. If the boat is in a static mode, there is no problem, but it is in a turbulence. It is creating a turbulence wave by the water, right? So we have went for MaxSurf, a special software specifically used by the ocean engineering department. And we created this special type of a lightweight concrete, right? Coming to self-compacting concrete, obviously it was invented by Okamura and Auchi. The main advantage, no compaction is essential for self-compacting concrete as we are using the workability agents. Earlierly, the people have went for two kinds of agents. One is to enhance the workability, another is to enhance the viscosity, to monitor the viscosity. So Conplast SP Superplasticizer 430 brand they have went for, and VMA viscosity modifying agent glinium based stream they have went for. Nowadays, instead of two Conplast SP 430 as well as VMA, they are directly going for master glinium stream 8233. In BASF, we are purchasing and we are using for our research purpose, which includes both workability agent as well as the VMA purpose. And the thing what you are using for self-compacting concrete, it should satisfy the FNOS specifications, where in our code, there is no a condition for self-compacting concrete. Even IS 10262 2019 code, if you see, they have coined for M40 concrete without admixture and with admixture, right? And the better appearance will be enhanced by going to self-compacting concrete, you just compare the conventional concrete CC with the self-compacting concrete. The outside finishes without plastering, you can see the SCC not need any plastering and all. So going to SCC based design, see normally if you are going for 10262, we obviously know that there is a step-by-step procedure. In IS 10262 1982 code of practice, there is a table will be there. Hope you people know that there is a correction factor will be applicable for sand as well as for water. Right? So here for SCC, we need to make it in a flow chart, trial and error. First, we need to choose the required properties. What are the essential property you need? For example, if I'm going for prestressed bridge or precast element, what kind of property I need to get for example, strength, what kind of that is split tensile I should have, the basic properties. Then I need to select the materials based on the desired property, my desired property. After selecting the material, actually they are directly going for design and adjust mixed composition. But after selecting the materials, you need to go for the testing. For example, if I am going for fiber, right, I can go for tensile strength study of the fiber, right? We are now telling that carbon, glass, aramid, it is giving much tensile strength than sugar molasses and other natural properties of the fibers, like that. So after selecting properties, you just come to the laboratory, just test it for the material properties, right? Next, design and adjust mixed composition. You need to arrive the mixed composition by fixing how much amount of cement you can use in terms of kg per meter cube. Because when you go to the FNAR specification code, there will be a table available. In the table, you can have cement, fine aggregate, coarse aggregate, so on so, total aggregate content and water powder ratio, how you can make it out in terms of kg per meter cube. This kg per meter cube to this kg per meter cube, we can take the cement. Like that, it will be mentioned. So you just take the basic ingredient, make the analysis. If it is suits your desired property, then go for next step or just revise the evaluate alternate materials. So here, many parameters will come into picture. You need to choose the proper workability agent. You need to choose the proper viscosity agent. You need to choose the proper grade of concrete. You need to choose the proper cementitious admixtures, like either you can go for fly ash or silica or blended type of cement, anything it may be. Or if you are going for aggregate, whether you are going for special type of aggregate or not. So varieties of parameters are come into picture. So in the case of evaluate alternate materials, you should be in position to evaluate very precisely. If there is a problem associated with aggregate, if you are altering the cement, then is absolutely no use, right? So, and finally, verify and adjust performance in the laboratory. Just see how the flowability is happening. And in addition, labor is not much essential for this case of SCC. Hope you people know that FNAR specifications, the workability test comes under slump flow, V funnel, L box, U box, J-ring, March cone test to fix the chemical dosages. Because in the conventional type of concrete, when you are going with, so you will do the workability test like slump cone test, compaction factor, PB consistometer, etc. So here, since we are fixing the zero slump, like collapse, it is almost collapse, right? So you have to go with these kinds of tests. The slump flow test, you should measure the T50 and T75, the spread diameter as well as the time taken for the spread. And you will have the permissible value, right? So if the time is coming quickly, if you are removing the mold, if it is quickly spreading, what it indicates, you have added the admixture in a over level, so that it is giving a pushing effect, right? So if the time is getting very slowly, example for V funnel test, if they are mentioning for 8 to 12 seconds, if it is optimum, if you are getting 15 seconds, then I can tell that the dosage what you have added is not to the level, or in other case, there will be a frictional between the concrete filled V funnel and to the side face of the V funnel. There is more friction, then your time lapse will be more, right? So initially you need to make the oil, you have to make the initial adjustments before carrying out the V funnel test. And you can see the specific dimensions of the V funnel test, what the people will generally use. And here it is a L box test. You know that the height difference between at the position of the reinforcement and the outside faces of the L angle. So here it is a U box test, where like a manometer test, you can able to measure the difference between R1 and R2. It is a rheological characteristics, right? So coming to fiber reinforced concrete, I have pointed here that fiber reinforced concrete is the concrete where additionally the fibers we are inserting. These are randomly distributed fibers we are inserting. So if you want to have additional details related to FRC, you can refer Professor Ravindra Gettu and his team. I will give you the name called Dr. Sunita Nair. She is the faculty in IIT Hyderabad, right? If you want to have more knowledge on fiber reinforced concrete, that too with more content of fibers, she has developed the PhD. She has worked for the PhD under the mentorship of Professor Ravindra Gettu. She used the Saint-Gobain fibers, which is the very costliest fiber. While you are doing for Saint-Gobain glass, the fiber will come right, the end product, the waste material that she has used for her research, and varieties of fibers she has used. And for notch test also they have performed using the PRISM study. They have went for notch test, and the equipment is available in IITM, IIT Hyderabad, right? Performing the notch test by giving the artificial crack at the flexural zone at the soffit of the beam. And they have studied for how much amount of energy absorption is happening by doing the rehabilitation work, right? And this is the type of kind of fibers normally used for FRC: polypropylene, polyester, glass, sugarcane molasses, carbon, steel, rubber, and some organic fibers. So if you want to purchase the fibers for your research or for the students project, I will point the company called Go Green Fibers. It is in Chennai. They are supplying both organic fibers as well as the advanced fibers like aramid. In the aramid also they are supplying the mesh type aramid as well as the shredded aramid, right? As well as for carbon fiber also they are supplying the matte type carbon fiber as well as for the shredded carbon fiber. So if you want to have the research for wrapping purpose, obviously you need to go for matte type fibers. And if you want to go for the internal enhancement of tensile strength, you can go for the shredded fibers, right? That too, like SIFCON technology, slurry infiltrated concrete technology, where you are pouring the fibers, a bunch of fibers at the below the neutral axis. So here many people are having in their mindset that after adding the fiber, we will increase the compressive strength, we will increase the mechanical properties in huge level. No, your compressive strength will not be enhanced by using the fiber type of material. If you go for the paper study for Ramakrishnan, Professor Ramakrishnan, you can able to get, if I'm adding the fiber, what will be the strength? If I'm not adding the fiber, what will be the strength? Right? So care should be taken that if you are going for sugarcane molasses, just have it a clear study that you are not experienced with a sucrose content, because if some percentage of sugar content is there, your setting time will be a huge problem, right? So the concrete will not set. So if the people, if they are not aware that the material what we are using, the natural fiber like sugarcane molasses, if I'm using, if there is a sugar content, they are not knowing, and suddenly if they are removing the prop shuttering, so there is a chance of destroying, right? So you should be careful that whether there is any sugar content is there. So that I have initially pointed here that after selecting materials in the second bar, you need to go for the testing properties, right? And you should confirm my material is stable enough. So you just see the different types of crimped steel fibers, and you can have the 3D fiber, 4D fiber, and 5D fibers. Dramix, the company like Dramix, Dramix, it's a US based company. They are supplying the Dramix kind fibers, right? Which will enhance the shear strength also. And in the bottom, you can see the polypropylene fiber. That too, if you see that PVA also will be like this, the bottom photo. The left side bottom photo, it is shredded fiber they have marked now. The PVA also will resemble like this, polyvinyl alcohol. It is also one of the expense-based fiber near to carbon, aramid, and glass. But it possesses good property, good tensile strength beyond 1000 MPa, right? And you can see the top carbon fiber. It is a mat-like fiber. It is also a shredded fiber. You can, if you want, you can get it in a roll and you can cut it whatever length you need. And you can see the optical fiber, where these kinds of fibers, you can see it in a picture tube and net cable, internet cable. You can see that this is the cable in a very, very core part, right? This lead will be in a core part. After the 3 layers or 4 layers only, you can get this product. In a picture tube, internet cable, you can get this. It's like an optical fiber, and coconut coir and jute fiber, you can also have it. So advantages: high tensile strength, toughness can be enhanced, impact resistance, and high energy absorption, right? So bacterial concrete, coming to this, how this bacterial concrete came and what is its speciality. So many people, even in civil engineering and also in biotechnology department nowadays, they are making the interdisciplinary research in the field of bacterial concrete, right? So here you can add the bacteria, that to calcite producing bacteria, right? CaCO3, calcite producing bacteria, you can add. The bacteria what you are adding, right, should be free from self-generating contaminants. The bacteria what you are adding, initially it will be in a capsule form. I will show you in the next slide. Normally it is called stain, right? How the bacteria is functioning inside the concrete is, it serves the food medium by its own, right? There are different types of bacteria like aerobic, anaerobic, varieties of forms and shade number is there for the bacteria. I will tell you where you can get it. This you can get it from MTCC, Microbial Type Culture Collection Center, Gene Bank, which is in Chandigarh. The bottom photo you can see the stain MTCC. We have got 121 and 1761. This is the type of stains we have got. It's like a pellet we have got for our research. Those who want to really pursue these kinds of bacterial based self-healing concrete, autogeneous healed concrete, you can get a letter from your institution and send to MTCC. In that, don't forget to give the identity number of the bacteria. So the identity number of the different forms of bacteria, you can get it from their website itself. N number of bacterial samples, cultures are available. But be careful that they have given the declaration. So without having their knowledge, you should not misuse that bacteria. Right? So you need to first study their rules and regulations and before using that bacteria for your experimental work. So after using that bacteria, bacterial stain, what we have collected, it is in a pellet form. So we have made a serial dilution in our food technology laboratory and part in microbiology laboratory. This is called culture making for how much requirement we need, that deals with serial dilution, right? That we have made, and we have studied for the DNA analysis of the bacteria. We have taken Bacillus subtilis of 50 micrometer analysis, and we have studied for the DNA what the profile looks like, the morphological characteristics, and we compared with the conventional concrete without the addition of the bacteria, and the same for the bacterial adding. So you can see the fracture plane in the conventional concrete and minute content of pores, and there is a lot of disturbances in the conventional concrete. Where this crack formation, initially if you are not very concentrating for closing, this is not the outer face what you are seeing. This is the inner face of the concrete. This is the inner face of the concrete you are seeing. If you are left alone, what it will happen? Obviously, your surface crack will be there. Due to bleed water, as I already told, due to overcompaction, the bleed water from the bottom surface of the concrete will come to the top and the bleed water will move up. So leads to the reaction with the different temperature, outside atmospheric temperature. So there will be a shrinkage cracks will occur, and some of the pores also will occur. Psychologically, if you see that pores is a very, very major drawback for creating the destroying. That pores will allow the contaminants from outside like carbon dioxide, nitrogen oxide into the concrete through the surface pores, and it will enter through these minute cracks which you are seeing now, completely destroying the passivating protective layer of the steel. That is the impermeable layer of the steel, leads to the formation of the rust. As we see that the volume of the rod will get enlarged and leads to the formation of the rust. Corrosion will happen, pH will disturb, and your lifetime of the concrete will get reduced. Once the steel reduces or loses its tensile nature, obviously your flexural strength carrying capacity of the RCC will be reduced, so that you are experiencing the spalling as well as delamination. The main nature of the spalling is because of the corrosion the bonding between the steel and the concrete will get disturbed, and in further cases, in years ago, your delamination effect, that is the cover concrete, will get fall off from the reinforcement. That is not a positive sign for the structure. So by using this, you can able to seal the crack by its own, which is called autogeneous healing. So bacterial concrete will be otherwise called as autogeneous healing, where you can see it from the calcite precipitation at the right side photo, the white-like patch appearances. Here I will enhance some doubt. Why not it can be a calcium sulfoaluminate, ettringite formation or something like that? It's a good question, but you need to make it in a zoom analysis that we obviously know that the ettringite will have a needle-like structure, right? It's a needle-like structure. The output will be a needle-like structure, and the surface area coverage will not be even. It's called tobermory gel, right? CSH will be a tobermory gel, and you can see the precipitation of Bacillus subtilis and the calcite formations, right? And in addition to that bacterial self-healing mechanism, we have also went for the lifetime analysis of the bacteria. This is a big question for us, big challenge for us. If I am adding one bacteria that I'm not much more enough knowledge about that bacteria. One client is asking to me, if I am, okay, I am agreeing you, if I am adding your bacteria, whether my structure will withstand for 1,000 years or 2,000 years, like earlier heritage buildings. For that, we need to go for a lifetime analysis for the bacteria in order to check the bacterial count, whether it is available in the core portions. Not in the core portions, evenly spread. Because we need to make the assumption that the bacteria has been mingled in all the portions of the concrete, like similar to FRC. FRC, in order to take the shear, also in order to take the flexure, the fiber should be evenly mixed with the concrete ingredients. But here, we need to properly manipulate that bacteria has been grown up or not. For that, the samples have shown the growth of the bacterial culture in the concrete sample casted with polyethylene glycol, where we have used the additional additive chemical admixture for self-curing agent. See, polyethylene glycol is one of the element which will enhance the internal curing. It is based on water-soluble polymers. And we have additionally add superplasticin VMA. The result confirms the presence of live bacteria in the sample after 24 to 45 days. So only we could able to get the up to the time of 245 days, the bacteria has been alive. After that, the growth has been it's not effective. So again, we have revised, we have studied why the growth is not effective. Because of the food medium or because of the oxygen level, like that. And still the research is in process, and we have tested in the department of my food technology in our institute. So coming to self-curing concrete, here obviously no curing is necessary, as you can observe from the two photographs. One, the tagline is conventional water curing. Another one is internal curing using the pre-wetted LWA. So what is the major difference between these two photographs? The photograph itself, the meaning is conveying that normally for the conventional concrete, we will use the external water. We will use the water from externally to cure the concrete such that the water will seepage inside, penetrate inside to the concrete ingredient, and it will get cured. So release of heat will happen. As the heat is sustained inside the concrete, what it will happen? moisture level will get reduced. Automatically, the hair-like crack will get developed, and your lifetime of your concrete structure will get reduced, as I already pointed in the backfill concrete slides. In the right side photo, in the left side photo, you just see the blue marking, water penetration has been marked right for the external water. What it indicates? See, very slow migration of water will happen when we are making like conventional type of curing. We are psychologically thinking that we are making the curing, but whether the curing has happening properly inside the concrete. If you are going to IS 456 class 13.5, they are mentioning a very significance to the curing categories. The types of curing like membrane curing, hot water curing, polyethylene type curing, all the types of curing. So if there is no proper in-depth coverage of water flow during the curing, the inside core concrete will not get proper water for the curing. Only the outer surface will get cured. Right? So if it is happened, if you are testing the sample, for example, if you are taking the sample, core cutting sample from pillar of the dimension 100 mm diameter by 50 mm height. Why they are making restricted to 50 mm means the cover is restricted to 50 mm. So if you are going beyond 50 mm, you need to cut the reinforcement. You should not do that. So they are making the diameter to 10 centimeter height, diameter to 5 centimeter height. They are taking away, they are going for RCPT analysis as well as carbonation analysis. And finally, they are computing that the specimen is weak under conventional type of design. So if you are going for internal curing concrete in the right side photo, you can able to get all the surfaces has been evenly maintained with the water for the curing. Where in the top place you can see normal aggregate is pointed, legend is pointed in black color, pre-wetted lighted aggregate is in the right side photo where the density is very less, and cured zone is almost covered for all the places. You can ensure a good characteristic strength of the concrete. So by using this self-curing technology, there is not much labor is essential for making the curing, and uniformity of the curing can be ensured, and Tobermory gel, that is CSK gel, can be uniformly formed. That whether it is formed or not, we have to observe from the SEM analysis. So here the technology is the curing. Normally the curing is from out to in. Here the curing is in to out, right? Into to the surface of the specimen. Just see the practical problems. Very tedious curing process and slower construction process, improper curing, periodical maintaining is necessary. And this is the disadvantages of the curing, and you can experience the corrosion, and this is called the delamination effect, where the cover concrete has been fallen off. So for that, we have went for checking the microstructural aspects, the internal durability aspects, by going to ASTM F2170 code of practice deals with relative humidity test, whether the humidity inside the concrete is maintaining due to the addition of self-curing agents. For that, we have taken a conventional specimen, cube specimen of 150 mm size. In abroad, they will call it as 158 mm size because they will take the coating of the epoxy also. The top coating as well as the bottom coating. So the top coating comes around 4 mm, bottom coating 4 mm. So the specimen height is 150, altogether 158. They are making 60% of minimum we have to go with as per ASTM F2170. We have to go as per 60% of the total depth of the specimen. So 100 mm we are making the drill, we are cleaning the debris, we are inserting the probe, and care should be taken that outside faces of the specimen should be covered with the wax film, and the rubber stopper should be made such that the humidity level from the container inside the container should go outside, and we are periodically maintaining how the relative humidity changing is happening. And you can see the formation of CSK gel for the self-curing specimens with the spherical size material. And this is the one of the advanced equipment we have purchased for our laboratory. This is called shrinkage equipment. This is called autogenous shrinkage based on German. This is a German equipment, ASTM-C 157 code of practice. In IITM, they are using with different types of design. You can refer Dr. Saktivel. He did his research in the area of shrinkage and creep in IITM under the guidance of Professor Gettu. So he has used a concrete cylinder to observe the shrinkage as well as creep, right? So the right side one, the corrugated tubes will be there, and dilatometer, which is a German-based equipment of high accuracy. Initially, you can go for cement paste or cement mortar. You have to fill it up, and you just fit in the device. Just maintain the admixture dosage properly and observe the reading, and you just see in a downward that how the strain is occurring. It is a negative strain, right? It is a negative strain, and you can plot it and observe the maximum strain, how it is getting for the threshold limit. They are did for water cement ratio of 0.3. So here you should not go for aggregate based thing. You can go for either cement paste or cement mortar, right? So vacuum concrete, you people know that it is for low water cement ratio. If we are pouring the concrete in the slab, the workability will be very, very less. So in order to make the good workability, we will add more water and we will finish the concrete, and the excess amount of water. For example, for the roof slab, if you want 0.4, right? If you are adding for the workability 0.5, you can release 0.1 using the dewatering mechanism, vacuum dewatering pumping. So the total testing time should not exceed 30 minutes, right? So while you are making, care should be taken that the fineness of the material should not come away, right? So this is a vacuum dewatering systems, the filter pad, sectional pad, and the pump, how they are using. And coming to geopolymer concrete, here no cement will be used. Only the materials like fly ash will be used here. What is the advantage? Here the emission of CO2 can be reduced. No curing is necessary because we are adding sodium silicate and sodium hydroxide. Polymerization will happen. So geopolymer concrete is also called as self-curing concrete, and it is more durable. So you can refer geopolymer concrete in Curtin University, right? Australia. Vijayarangan, Professor Vijayarangan paper, you can refer it out. And this is a sample mix design. You can go for different gradation of aggregates starting with 20, 14, and 7, where for effective pore filling, if you see that 7 mm size, more volume they have used, and for 20 mm size, less volume they have used, because if you use 20 mm size of more and 7 mm of less, then it is not necessary to fill the gap. So automatically your intrusion of the cement paste mortar will not enhanced. So the first low quantity will be 20 mm, the big quantity, that pore size will be filled by 14, that pore size will be filled by 7. And fine aggregate, you just see that altogether it's coming around 1,100 kg per meter cube, the aggregate content. And the fly ash they are using for low calcium ASTM class F fly ash, which deals with that powderaceous content where I have told for SCC, and sodium silicate based on different molarity they are using for sodium hydroxide and sodium silicate. And sodium hydroxide, they fix the molarity for 8 molar for trial 1 and 14 molar for trial 2. And superplasticizer they are using for 6 kg per meter cube, and extra water For mixture 1, they have not used any extra water, and for mixture 2, they are going with 22.5 extra water for the analysis purpose. Here you can see the observation of the compressive strength in terms of MPa for different types of alkaline solutions, and averagely they are designing for M30, right? But still they haven't achieved their target strength. They are observing for 1 to 20 days of curing. So the applications, they are going for culvert, they are going for prefab walls, like that. So polymer concrete, it's nothing but, it's similar to FRC, concrete ingredients plus addition of polymers. You know that polymers is group of monomers. There are 4 types of polymer concrete: PAC, polymer impregnated, polymer cement concrete, polymer concrete, and partially impregnated surface coated polymer concrete. And what are the general monomers we can use for preparing the polymer concrete, like methyl methacrylate, styrene, butadiene, furans? Apart from this, many monomers are also having, but these types of monomers which will significantly improve your concrete properties and make the concrete to be more sustainable. And the properties, you can see the density, they are checking the tensile strength, compressive strength, and you can able to achieve 110 to 125. High strength concrete, you can able to get it, and bending strength, you can able to get 25 to 35 MPa, right? And you can get the efficient thermal conductivity, right? So no fines concrete, the next special type of concrete is no fine aggregate will be used. Here only the cement plus very small quantity of coarse aggregate of size 10 mm and 12.5 mm will be used. So it is mainly applicable for rainwater harvesting, because more government is frequently telling that every residential houses, the people should make the rainwater harvesting tank, not to collect more water for the future purpose. And you can see how much of water percolation is happening. And we can use this type of concrete for pavement, parking slots, and the outside faces of our residential place. And this is the table showing the material, how much we can take, the mixed design, aggregate to cement volume ratio. And if the aggregate to cement volume ratio is increasing, automatically the strength is getting decreasing, right? So it is not getting balanced with that particular water cement ratio. Obviously, you just see that for 6 aggregate to cement volume ratio, the water cement ratio is 0.38, and for 10 A by C ratio, your water cement ratio is 0.45. So if the material content volume is getting increasing, the strength is automatically getting decreasing, right? So you can decide the average strength, what it is necessary for your parking slots or for your blocks, anything it may be, right? Then you can decide. You can go for a precast also, precast manhole. You can design for the precast top layer, the lid, right? So with this, I complete my presentation. The time is now 1:10. Thank you so much. Now the forum is open to you for the discussions. Thank you.
Thank you very much, sir. Now the participants can ask any questions or any clarification, please.
Am I audible, sir?
Yes, sir. You are audible, sir.
Good afternoon, sir. It was a nice presentation, and it's we were all really thank for the organizers for having this kind of a session. My question to GS Ramapradeep sir is what is the procedures or methods to test the durability of these concrete, especially bacterial concrete over a long period of time, and how these kind of concrete will be resisting the chemicals or environmentally at worst conditions?
Okay. So, good question. So, if you see that not only the durability in the sense, I'm pointing for all the research people. So, if you are going for every kind of research, don't stick only to the mechanical properties and structural properties. At the end, you should produce the durability properties so that the upcoming researcher should able to know the clarity of your research, right? So I'm generally telling, not only for bacterial, I'm generally telling, but I will come to the bacterial also. Durability point of view is concerned, is a long time analysis. Indian code is not specifying much more on the durability cases, but nowadays they are trying to incorporate like oxygen permeability, water permeability test inside the code of practice. And if you want to go for durability test, you need to refer ASTM. Like if you want to assume that you are doing in self-curing, right? You are adding like water-soluble polymers or any other material. You are saying that the water is maintaining inside it. Not water, the moisture is maintaining inside. Whether you need to prove that. How you can prove? For that ASTM F2170 code of practice, by drilling that core, you need to insert the probe, observe the relative humidity. Then you can come to the conclusion that so that the code of practice is telling 60%, more than 60%, you need to be, that is below the neutral axis, you need to insert the probe after cleaning the debris and observe the moisture content, plot the graph, get the threshold limit, whether it is getting sudden declining or the graph is getting linear. The angle is very, very less. This is the one case you can go with. Other durability tests, you can go for ASTM C1202, that is RCPT content of analysis, which is a very prime most. While I have told for when there is a hairline crack, right? If you go for RCPT, you will use NaCl and NaOH, right? In one acrylic cell, you will go for NaCl, and another acrylic cell, you will go for NaOH. Then the passage of these chemicals, which will disturb the pores content, which will disturb, right? So based on that, the Q value will be given in the ASTM C1202 code of practice or ASTRA code, anything it may be. From that, after by Q value that is equal to 900 plus I into like the formula will have. After 30 minutes interval, you need to monitor the reading, and from that you can able to get it how much amount of chloride has been penetrated. If you are using bacterial concrete, you are saying that if the bacteria has been arrested the crack, hairline crack, bacteria will not arrest the major crack. If the bacteria arrests the hairline crack, then obviously your intrusion of the NaCl will not be there. Then your RCPT value will be good, right? So again, you can go for any other modern test like corrosion analysis, right? If you going for water absorption analysis, or you can go for shrinkage analysis, anything you can go with, right? So I think I have.
Thank you, sir. Thank you very much.
Thank
You clarified the doubt.
Okay, thank you.
Anybody else, please?
Or if you are struggling to ask any questions in a public forum, my mail ID is within the organizer, and my mobile number also is with him. You can post me the questions at any time. And if you want to discuss with me, my mobile number is also available with the organizers.
Thank you very much, sir. This open mind, sharing the knowledge, we are very happy to be associated with you. Definitely, I will call and talk to you. Thank you.
Thank you. Thank you, Manish. Thank you.
Thank you very much, sir. Now we are coming to the end of this session. Dr. Ram Pradeep sir dealt clearly about special concrete, that is mainly connected with reduction of carbon emission, and he also told about the sources for doing for carrying out R&D works. He dealt lightweight concrete for lightweight board, self-compacting concrete, mixed design for that also, and various tests involved in self-compacting concrete. And he also dealt fiber reinforced concrete, and for that different types of fibers for FRC. He dealt bacterial concrete, SEM analysis for microstructural properties of concrete, vacuum concrete. He dealt in a very detailed manner. He's a very good personality, very kind person. Participants can contact at any time. He is of helping nature. At any time we can contact. He will help in all ways. You can get all types of doubts related with concrete. He is able to clear all your doubts. Thank you very much, sir. Participants, now the session is over. We will meet by 2:15 p.m. for the afternoon session. Now we are leaving for the lunch session. Thank you. Thank you very much.
Thank you all the participants. Thank you.
అన్ని వేడి నీళ్ళు తాగలేము, అంత వేడి. అది నేను అనేది, ఇది వేడి ఈవినింగ్ దాకా అలానే ఉంటుంది.